Hello students, how are you? I hope you are doing good. So here we are with the lecture number 5 of geometrical optics that we have started. Okay. So how are you guys? Just if you have any kind of discussion type of thing, you can just write it in the chat box. Okay. So we are starting the lecture of geometrical optics. Okay. If I'm audible to you and this screen is visible to you, then please respond in the chat box. Yes. Okay. So that I would start the class. Okay. Got it? Tell me if the screen is visible to you, all of you. Hello, Ram Babu. How are you? The screen is visible to you or not? Just reply in the chat box. Okay, Nandini Reddy. Thank you so much. And audible too. I'm considering this is the answer for audibleness also. Okay. So let's just start with the lecture. Just give me 10 seconds. Okay. Okay, guys. So we are here with the geometrical optics lecture number 5. So as Nandini Reddy has answered that his screen is visible to, I'm considering this answer for all of you guys. So I'm starting the lecture now. Okay. So here we are with the geometrical optics lecture number 5. Aim for today is what? Yes, we have to set the aim, na, firstly. So what is the aim for today? Firstly, we are going to recall some concept that we have learned in the previous chapter, previous class, must say. Then the path of refraction in the glass slab. Okay. And its shift, lateral shift and normal shift. You will know what is this. Okay. Then we are going to learn about the real depth and apparent depth. What is this? We are also going to do this. Okay. Then total internal reflection and critical angle. Okay. So this is it that we have to do for today. Okay. So now the very first topic is the reflection. Okay, Ram Babu, thank you. Now just focus on the lecture. Okay. So we have learned in the previous class that what is a refraction is. So what the refraction is, I have tell you that if the ray is passing through a transparent medium, okay, if a ray is coming from a medium and passing through a transparent medium, both the medium are different in refractive index, in the optical density. Okay, then the light would deflect from its path. Okay. That is the refraction. And what is reflection? Reflection is the when you have a polished surface, then light coming and sent back to the same medium from the boundary is termed as the reflection. Yeah. Now, yeah, you can read the definition also. When a light ray travel from one transparent medium to another transparent medium, it deviates from its original path. Okay. And the phenomena of change in the path of light at the medium of separation is called refraction. Hello, Senait, how are you? So, this is we have as a refraction. You can see here. This is the incident ray. This is the incident ray that I have. Yeah, this is the incident ray, and it strikes the boundary of a transparent medium. It goes inside the medium, and it's changed its path. Originally, the path would be like this, but it has changes its path. Okay. Yeah. So what we are going to do now, the next part of it. Just a second, huh? Okay. So laws of refraction that we have discussed in the earlier chapter, the incident ray, normal ray, and the refracted ray, okay, always lie in the same plane. Got it? This is the first law of refraction that we have. ऐसा नहीं होगा कि rays coming from this plane and going in that plane perpendicular to you or any of the angle. ठीक है? From the plane, it is not going to happen. All the rays and the normal to the surface will lie on the same plane. Got it? Now, second law is the Snell's law. We have studied it. It is nothing but it tells us about the ratio of the angle of incidence, sine of angle of incidence to the sine of angle of refraction is equals to a constant quantity. And what is that constant is? This constant is nothing but the refractive index of the medium. Here you can see that this sine I, just a second, this sine I by sine R is nothing but this sine I by sine R is nothing but the refractive index, relative refractive index, mu2 by mu1. Okay. And I have told you, this is the plane you have. This is the normal to the plane. Incident ray is coming, bending means, what does it means? It means that this has a refractive index mu2 and this has refractive index mu1. Okay. So if it is bending towards the normal, which means mu2 is larger than mu1. I have told you about all this. Okay. This angle is I and this angle is R. Okay. So for applying the Snell's law, what we can do? We can do is this mu1 sin I is equals to mu2 sin R. Just multiply the angle of incidence with the respective refractive index and angle of refraction with the respective refractive index. Okay, this is it about. Okay. Now moving on to the next slide. Refractive index we have talked about. Refractive index is nothing but it indicate the optical density of any medium. Okay, optical density for light, it is representing. It also, you can also remember this term as the frictional, optical friction for light. Light is coming in a medium and it changes its path. Why? Because the speed of light got changed. Okay. स्पीड ऑफ लाइट चेंज होने का मतलब है कि स्पीड ऑफ लाइट रिड्यूस हो रही है, कम हो रही है, गेटिंग रिड्यूस्ड. और जब स्पीड रिड्यूस होती है, दैट देयर इज मस्ट बी अ ब्रेक we have applied. So this refractive index is nothing but the brake applied by the medium to the light. So this is the frictional, optical friction provided by medium. किसके लिए? To the light. Got it? So you can learn this as a refractive index is a medium defined as the factor by which the speed of light decreases. ठीक है? Speed of light reduces. And it is nothing but mu is equals to velocity of vacuum, क्योंकि vacuum में सबसे ज्यादा स्पीड होती है लाइट की. So velocity of light in vacuum divided by velocity of light in a medium. This term, this mu, which is the ratio of speed of light in vacuum to the speed of light in the medium, is termed as the absolute refractive index. ठीक है? It is not measured with any one of the other medium and with respect to the another medium. And if we measure the refractive index with respect to another medium, then what it is called? It is called the relative refractive index. It is same as, like in your class there are 10 boys. Okay? and they have different heights. Got it? So what you are going to do, there is a two method you can apply. You take the meter and measure the height one by one. So you got the absolute value. Okay, suppose there are three students, Ramu, Shyamu and Ganesh. Okay, so if I measure the height of each of them by meter, Ramu is 5 feet, Shamu is 6 feet, let's say, and Ganesh is 4 feet. So these values are the absolute one. But what if I consider, because Ganesh is the smallest and Shamu is the largest one, the 6 feet. So what if I measured that their height with respect to one another? If I consider Ganesh सबसे छोटा है, I will consider that. Then what we can do? We can say that Shyamu is 1 feet larger than Ganesh, and Ramu is 2 feet larger than Ganesh. So this is the relative term that we have used. Same goes for the refractive index. If you measure the absolute value of refractive index, it is the absolute one. If you measure the refractive index with respect to another medium, that is the relative refractive index. Got it? Yeah. So here you can see this mu A by mu B. How are we going to write it? We are going to write firstly A. This A, which is in the numerator, going to the backward side, and this mu B come in the first side. So it is nothing but medium A से जब light medium B में travel कर रही है, then the path of light goes deflected. The ratio of their refractive index is termed as the relative refractive index. Got it? This bu is nothing but refractive index of A with respect to B. Okay, relative it is nothing but refractive index of A with respect to what? With respect to B. Got it? इसे थोड़ा प्रोनाउंस करना थोड़ा सा क्रिटिकल होता है ना. सो जस्ट रिमेंबर इट. जो प्रीवियस साइड है, इसमें आप लेफ्ट हैंड साइड की तरफ मूव करो. फ्रॉम ए टू बी जा रहे हो, तो यानी कि रिफ्रैक्टिव इंडेक्स ऑफ ए विद रेस्पेक्ट टू बी. लाइक अगर यहाँ पे लिखा होता सी म्यू बी, सो व्हाट इट इज रिफ्रैक्टिव इंडेक्स ऑफ बी विद रेस्पेक्ट टू सी. गॉट इट? आई होप यू आर क्लियर विद दिस. नाउ लेट्स मूव ऑन टू द नेक्स्ट टॉपिक. Yeah. So we have this question. I am giving you around 30 seconds to solve this question. Then I am going to solve it for you. Okay. So you guys have 30 seconds. Just try to solve this question. It is based on the Snell's law. Okay. I have done a question in the previous class also. I have remembered it. So it is nothing but the Snell's law. Just try to solve this question. Got it? And if you have any doubt in the previous slide, like in the recoil one, you can ask. You can unmute yourself. Okay. So I'm giving you 30 seconds for this, guys. Okay. Just try to solve this question. Okay. You have to apply the Snell's law in this question. Okay. Try to solve. If anybody goes the answer, just write it in the chat box. Okay. Okay. So I'm trying to solving it for you. Let's go through the solution of this question. Firstly, yeah. Solution. If any point of time in this lecture you find my screen is not visible and I'm not audible, please remind me in the chat box. Okay. So solution of this question is nothing but we are going to read this question firstly. So a light ray is incident on a glass sphere at an angle of incident 60 degree as shown. Find the angle R dash and E and the total deviation after two refraction. Okay. So these terms I have to find out. Okay. So firstly, what we are going to do, This is the sphere. Okay, has anyone got the answer? No. Okay, this is the sphere we have. This is the incident ray making an angle 60 degree. Going through this is the, again, it is the normal to the sphere and it is E. Now we are going to apply Snell's law. Snell's law क्या कहता है? Multiply the angle of incidence, sine of angle of incidence with the refractive index of this medium. The it is air outside, refractive index n is equals to 1, and for the inside one n is equals to √3. Okay, so we are going to apply the Snell's law. It is n1, or we can say mu1. Here n is the representation, so I am using n1. N1 sine I is equals to n2 sine R. Got it? What is the value of n1? N1 is n is equals to 1, refractive index of the outer medium. 1 into what is the value of I? I is the angle of incidence, which is 60 degree. It is sine 60 equals to, what is the value of n2? It is n is equals to √3. √3 sine R. Okay, the angle of is R over here. You can see in the figure of the question. This angle is R, angle of reflectance. So here, what is the value of sine 60? It is √3 by 2. √3 into sine R. Okay, √3 got cancelled out. Sine R is equals to 1 by 2. And what is the value of sine R 1 by 2? It is sine 30. So R here is 30 degree. Got it? So this is the answer to our first question. We have find out the value of R. In this pair, this is the circle is shown to you. Okay. This is the chord that cutting it. And this end point of this chord is connecting to the diameter. So there is a theorem. If this angle is A and this angle is B, so this angle A is angle equals to angle B. Okay. So you can see in the question, you can see in the figure, this is the R and this is R dash. Okay, these chords are connecting to the point and these points are meeting at the center of the sphere. So we can consider from here that R is equals to R dash, which means R dash is nothing but also 30 degree. Got it? Okay. Now what we have to find out? We have to find out the deviation. So what is the deviation in first case? In first reflection, let me change the color of it. Yeah, this is the sphere you have. Okay, this is the center. Now this is the diametral I must have to draw. Okay, now yeah, this ray is coming in this way. Yeah, and going in this direction. Okay, and again this is the normal and this ray is moving away from it at an angle of E. Okay, this angle is 60. This angle is R. This angle is R dash. This angle is E. So for the first deviation, you have to see this is the original path, which this total angle is 60. This angle is I also. Okay. So the deviation from it, this value will be the deviation of it. Okay. This is the deviation. This total angle is 60. This total angle is 60. Okay. This value R is 30. So what is value of this? This total angle here is I, and this is the angle R. So what is the value of deviation? It is I minus R for the first delta 1. It is 60 minus 30, and it is nothing but 30 degree. Again, this ray is going in this direction, means this is the value of R dash. This is value of E. Okay. Now the deviation is nothing but R dash minus E. Have we found out the value of E? No, we have only find out the value of R dash. So no problem. We are going to apply the Snell's law again. And what is Snell's law? The Snell's law is nothing but, okay, the inside medium has n is equals to root 3. Outside medium has n is equals to 1. So we are going to apply n in a root 3. N sine R dash is equals to 1 sine E. What is the value of n? N is root 3. What is the value of sine R dash? Sine 30, which is 1 by 2. 1 into sine E की value क्या होगी? This is sine E. Sine E is nothing but root 3 by 2, which is 60 degree. Okay. So this entire angle, this total angle is E. This angle is R dash. So we have a value of deviation, second deviation, delta 2 is equals to what? It is nothing but E minus R dash. E we have calculated 60 minus 30, again 30 degrees. So total deviation is equals to delta 1 plus delta 2 equals to 30 plus 30 equals to 60. Okay, so we have got the answer of it. If anyone have any problem in this question, I will re-explain it. Just write it in the chat box to make sure. Okay. Now the next question that we have, this question is really conceptual and it will help you a lot. Okay, in your preparation part. So again, we have this question. I will solve it in myself. So a ray of light passes through a medium whose refractive index varies as. So here we have a variable refractive index. In the previous problem, the reflective index is same everywhere. Like for the outside, it is n is equals to 1. And for inside, it is n is equals to root 3. Okay? But here, the refractive index is variable and it depends on the position. You have seen in the expression, n is equals to n naught 1 plus x over a. Means it depends on the value of position. Okay? And who is going to move? The ray is going to move. Okay, it will depend on the value of position. Okay? If ray enters the medium parallel to the x-axis, what will be the time taken for the ray to travel between x is equals to 0 to x is equals to a? Got it? So suppose this is the axis we have. This is x-axis, this is y-axis. A ray is coming. This is a ray. Okay? And this is the medium we have with refractive index n, and which is variable with respect to x. So this ray, like this value is x is equals to 0, and this ray has moved here to here. X is equals to a, and it has taken time t. Okay? And it has started its journey from time t is equals to 0. Okay? So for the solution of this question, what we are going to do, we know that it's a very simple question. Okay, if you try it, we know that this refractive index n, here it is given as n, and we have discussed all about the refractive index in terms of mu. So it's just a matter of symbol. It mean nothing. Okay, so whatever you can use n, you can use mu. So here we are using n. So we have seen in the previous recall part that refractive index is nothing but it is the ratio of speed of light in a vacuum to the speed of light in the particular medium. Okay. So from here, what we can do, we can write it as V is equals to C by N. Okay. And V is nothing but we can write V as dx by dt, change of position with respect to time. So C by N we have. Okay. So dx by dt is equals to C by N. We have provided that N is equals to N naught 1 plus X by A. So put this value in this equation. Dx by dt equals to C by N naught into 1 plus X upon A. Okay. Multiply, the cross multiplication takes place here. So it will become N naught into 1 plus X over A dx equals to C dt. Okay. Now what we are going to do? We are going to integrate this term. Okay. We are going to integrate this term. And from where to where we have to put the limit. So what is the limit of x? Limit of x is nothing but x is varying from x is equals to 0 to x is equals to a. We are interested in this limit also. Okay. And time t is equals to 0 to t is equals to t. Okay. So just put this value 0 to a. This is the here the variable is x. So limit is put 0 to a. Here is time. So 0 to t. Now if you integrate this term, it will become as n naught integration 0 to a dx plus n naught by a. I have taken a as outside, x dx, and this is the integration 0 to a, and this is equals to c outside, which is the constant 0 to t dt. Okay, got it? Now on this part, this integration is nothing but x 0 to a. This integration is nothing but x square by 2, 0 to a is equals to, this integration is nothing but c t 0 to t. Okay. This I hope you have remembered the basic formula for integration part. Okay. That must have been taught to you in physics also. So n is equals to n naught. Put the limit. It is a minus 0 plus n naught by a. It is a square by 2 minus 0. Okay. Is equals to ct. Got it? So this a and this a will cancel out the one a of it. So it is n naught a plus n naught a by 2 equals to ct. This will gives you 3 n naught a by 2 equals to ct. So we have to calculate the time. So it is 3 n naught a by 2 c. So this is the value of time that we have. Got it? A handout you can ask, or we will move on to the next slide. Okay, just write it in the chat box if you are clear with this question. Just write it. I'm waiting for your response. Yeah, please write. Okay, if this question is clear to you, please respond in the chat box. Yeah. Okay, if you have any doubt you can ask in the chat box, and if it is clear to you, just write into the chat box. Is Nandini Reddy here? Ram Babu, I'm asking for you guys and for everyone which is present in the class. Okay. Yeah, Bhavna is there, Devan is there, Snehit is there, and 10 more member is here. So please reply in the chat box if you are clear with this question. If you have any doubt, you can ask. Okay. So moving on to the next slide. Yeah, the path of ray of light through a glass slab. So whenever a light ray passing through a glass slab, okay, glass slab. What is a glass slab? Glass slab is made up of glass. Okay, there is no concept in it. But here a very interesting phenomena taking place, the refraction. Because light is entering from one medium to a transparent medium, so it will deviate from its path. And since it is a glass, which is the heavier one, optically denser than air, so light will bend towards the normal. As you can see in this picture also, here you will see that this is the incident ray, okay, coming through directly from air, got it, and going through the glass. So it is bending from normal. It has to take this path if it is not bending, but it is bending towards the normal, to the surface. Why? Because this is the optically heavy medium. Okay? This has a refractive index mu. Got it? Let's say this angle is I, this angle is R. Okay. So this ray come here again. This is the boundary it has encountered. Again, it will have the refraction because it is going from one transparent medium to another transparent medium. So this transparent medium is heavy. We have glass, and this transparent medium is air. Okay. So it moves away from the normal. When light go from denser to rare medium, it moves away from the normal. So it is moving away from the normal, you can see. Otherwise, it will have to move in this direction, the white dotted line. So this angle is this angle is nothing but, you can calculate this angle. This angle is R. This angle is 90 minus R. So this angle will be R. Okay. And what is this angle? This angle is E, the angle of emergence. ठीक है, जिस एंगल से बाहर आ रही है, इमर्ज कर रही है, that angle will be calculated as angle of emergence. Got it? Okay, so you have to calculate this shift, because if there is an observer, okay, if there is an observer here, what will have to appear to this observer? This ray is coming directly to this path. Okay, this ray is coming directly to this path. So there is a lateral shift in this direction. In that direction, this is the previous one direction, the ray of incident ray direction. Although this ray, the ray 1 and this ray 2 are parallel to each other, but they have got shifted by some length. And why it is so? Because of this glass slab. Okay. So this parallel shift of rays from one another because of a medium, because of a glass slab, is termed as the lateral shift of the glass slab. Got it? So if I want to calculate this lateral shift, how we are going to calculate? Now look at this point. I have drawn a normal to this ray. Okay, and this length is nothing but L. Lateral shift L. This point is A, this point is B, this point is C, and this point we have considered as D. Okay, okay. So if you see in triangle ABC, okay, in triangle ABC, if I apply the, this is A, B, C, this triangle we have considered. Okay, if I apply sine R in triangle ABC, what is the value of sine R? Sine R is nothing but this length, this length, this diagonally length. And one thing that I forgot to mention here is the length of this glass slab is, the thickness of this glass slab is T. So firstly, this A and C. So sine R is nothing but sine R. What is the value of sine R? Sine R is the perpendicular over hypotenuse. What is the perpendicular here? Perpendicular is this length BC. BC divided by AC. Okay, and in triangle ACD, in triangle ACD, D. Again, apply this because we are interested in this length L. So this angle is nothing but I minus R, because the total angle is I, this angle is R, you can see, and this total angle is I. So what is left? I minus R. So if you apply sine I minus R, I minus R is equals to nothing but what? This is the perpendicular CD and this is the hypotenuse AC. CD over AC. Got it? Now, for for paraxial ray, paraxial rays, paraxial rays means जो एक्सिस के पैरेलल होते हैं, ठीक है. So for paraxial rays, these angle I and R will be very short, very less. Okay. So for paraxial ray, I and R are very small, very small. So we can consider sine I minus R as approximate I minus R. Okay. And sine I, yeah, sine R approximate to R. Got it? Now, if I apply the Snell's law in the previous question, in this previous situation, this is the glass slab we have. This is incident ray, angle I, going reflected, refracted, again moving out. Okay. If I apply, this is the air, which is n is equals to 1 or mu is equals to 1. This has mu, value mu, and this again is air, mu is equals to 1. So if I apply Snell's law here, apply Snell's law, what we will get? Mu1 sin I, mu has value 1 in the first medium. So we can write 1 sin I is equals to, this angle of refraction is R and the medium is has effective index mu. So mu sin R. Since these I and R are very small, we have discussed in the previous slide. So we can directly consider sin I as I. Sin I as approximated to I. And sin R are also approximated to R. So we have I is equals to mu R. This is the equation number 1. Okay. From the previous one, from the previous equation, what we will get is sine I minus R is CD over AC. Okay. Sine I minus R is CD over AC. Okay. So this is the lateral shift that we are talking about, L. This is triangle ABC and this is triangle ACD. Now this length is T. Apply, we have to find out this AC in terms of this T. So if you apply cos R in triangle ABC, so in triangle ABC, what is the value of cos R? Cos R is nothing but base over hypotenuse. Base is AB, which is nothing but T. And what is AC? We have to find out. So AC is nothing but T over cos R. Okay. Put this value in this equation. So we have sine I minus R is equals to CD. What is the value of CD? CD is L, lateral shift. And what is the value of AC? It is T over cos R. So T into cos R. Third place goes upward. Okay. So L here is nothing but sine I minus R, sine I minus R divided by cos R into T. This is L. So this is the value of lateral shift that you will got. Okay. Got it? Now, If you have any doubt in this, you can just write it in the chat box. Okay. Otherwise, we will discuss some of the important cases over here. Yeah. So if you guys have any trouble in this lateral shift, you can just write it in the chat box. You will get a variety of numerical question from this concept. Okay, so it is a very important concept to learn. If any doubt, just ask in the chat box. Okay. So we have this L is equals to sine I minus R by cos R into T. If I is equals to 90 means जो इंसिडेंट हो रहा है वो वर्टिकली हो रहा है, rays are going along the normal to the incident ray. Suppose this is the ray and this is the boundary we have, so it is going like this, perpendicular or in the direction of normal to the surface. So what will happen? It will create sine. What is the value of I? It is 90 minus R. Sine 90 minus R is nothing but cos R from the trigonometry. So L here is sine, sorry, sine I minus R has been become as cos R divided by cos R into T. Cos R and cos R will get cancelled out. So we have lateral shift just equals to the thickness of the glass slab. Okay. Now the second case, if I and the angle of incident I and R are very small, and for which these angles are going to be very small, for the paraaxial rays. Okay, so just remember it, very small. So we have sine I minus R is approximated as I minus R, and cos R is approximated as R, sorry, 1, because as R got very small value, so co is got nearly 0, so cos 0 is nothing but 1. Okay. So L we have, L is equals to I minus R divided by 1 into में T. Okay. So from Snell's law, we have a relation here. I is nothing but mu R. So we put the value of R is equals to I by mu. So what do we get? L is equals to Ti 1 minus 1 upon mu. Got it? Why we have put the value of R? Why not I? Because I is known to us. We can control the angle of incidence. Okay. We have known the value of thickness of the glass slab, and we have known that what material we are using. So these all values are known to us, but this R is not known to us. You are not going to deep down in the glass lab and look at the angle of R. Yeah. So that is why we have put all the values that is known to us. So this is the lateral shift that we have. Got it? Now, if you have any problem, you can just write it in the chat box. And if you are clear with this concept, just write it in the chat box. Okay. Now, next slide we have, it is for nothing. It is the normal shift that we are going to talk about. Okay. Got it? So that lateral shift is the parallel to the incident ray. Okay. Parallel to the incident ray. And this normal shift is nothing but it is the shift in the position of an object with respect to the normal. Okay. So here we have an object. Here we have an object. These rays are coming down perpendicular to the, so it will not get deviated going in as it is coming from the medium. So this is the normal incidence of the light. And this ray is going in this direction. This is the angle of incidence. Again, this is the angle of reflectance, which is R, because it got bend towards the medium. So it is mu, and here mu is equals to 1. Again, this angle is nothing but what is the value of this angle? It is E, angle of emergence. Okay. Now, if you look at this object is here. But if there is an observer here, like there is an observer which is looking at this, so this ray appears him to be coming from here. Okay? You will see to formation of the image, two ray have to meet. But if you see this ray number 1 and ray number 2, this will never going to meet. Okay, these are diverging. So they has to move in the previous one. In this section they has to meet, and this is the virtual position of the image. Okay, so if I extend this ray, so it would appear to coming from this position. So this is the shift in the normal direction to the object. So that shift is termed as normal shift, which is having a value of x. So we have to calculate this value. What is this? So we draw the perpendicular. This shift is nothing but, if anyone can recall this, what is this shift? What is the value of this shift? We have already calculated this. This is nothing but it is the lateral shift that we have. Okay. So this value is L and this is X. This angle is I. So same as this angle would be I. Okay. If you apply sin I to this triangle, I must name it at O, A, B. Okay. So in triangle OAB, in triangle OAB, if you apply sin I is nothing but perpendicular over hypotenuse. Hypotenuse is perpendicular is AB. And what is the value of hypotenuse? It is OA. So sin I is equals to, what is the value of AB? AB is nothing but lateral shift. And what is the value of OA? OA is the X, the normal shift that we want to calculate. So for paraxial rays, these all cases are discussed for the paraxial rays. Paraxial rays, this I is very small. So we would consider this sin I as approximate to tan I. Okay. So, and this tan I would be considered as I small. Okay. So it is nothing but I is equals to L over X. X is nothing but L over I. Okay. And we have calculated the value of L in terms of I. So we just put it here. What will be the value? Value is Ti into 1 minus 1 upon mu. So Ti 1 minus 1 upon mu divided by I. I and I will got cancel out. So normal shift we have I is equals to thickness of the slab 1 minus 1 upon mu. Got it? So if you have any doubt, you can ask in this. You can write it in the chat box. Otherwise, if you are clear with this, just try to mention in the chat box also. Okay. So are you getting it? What I'm trying to say you? Devan is there, Thanu is there, Sudipti is there. So are you guys getting it? What I'm trying to say you? I hope you are getting it. Okay. Just write it in the chat box if you are getting it, or we will move on to the next slide. Okay. Yeah. So we have done with the lateral shift and normal shift of the ray. Okay. Tanaya is also there. Okay. So if this concept that I have taught to you is clear to you, just write it in the chat box. So if you guys will be responsive, it would be a very interactive session for me also. Okay. Now the few important concepts that I want to discuss from the previous slides that I have tell you. Okay. So in this, there is a liquid we have of different refractive index material has been filled in this container. Okay, so three immiscible liquid of refractive indices mu1, mu2, and mu3. where mu3 is greater than mu2 and mu2 is greater than mu1 are filled in a vessel, and their depth are d1, d2 and d3 respectively. Then the apparent depth seen from the first liquid will be given by. So it is given by thickness of the first liquid, it is d1, it is d2 and it is d3. Okay. So it is given by d1 by refractive index of the respective liquid plus d2 by refractive index of this liquid plus d3 by mu3. So this is the apparent position seen from the first liquid. Okay. And the normal shift in the position of image, again we have done with the normal shift. It is nothing but the thickness multiplied with 1 minus 1 upon mu. Here we have 3. You can consider these liquids as glass slabs. So we have 3 glass slabs here. So for this the shift will be d1, the thickness of this glass slab, 1 minus 1 upon mu1 plus for this it is d2 into 1 minus 1 upon mu2 plus for this it is d3 into 1 minus 1 upon mu3. Got it? So these two formula are very important. Just try to learn this. Okay. These are directly applied to the questions. Got it? Now, real and apparent depth we are going to talk about. What is the real depth and the apparent depth? So whenever the object and observer are placed in different medium and they observe their position, okay, they observe their position. So there is a shift in the actual image. You have also seen then in a glass lab that in a glass water is filled, okay, and you put your pencil. So this is the apparent shift in the position of the pencil length inside the liquid than the outside one. So this is all happening because of the different refractive indexes of the liquid. Okay. So we are going to discuss what is the real depth and apparent depth in different cases. Okay. Suppose this liquid has medium has a refractive index mu1 and this has mu2. Okay. This ray is coming, just a second, this ray is coming from this is the observer that we have, object, it is nothing but object. Just a second, it is nothing but object. So from this object ray is going, this is the value of I, sine angle of incidence, and as mu2 is greater than mu1, so this ray is moving from denser to rare medium, so it will move away from the normal. So it is moving away from the normal. This angle is nothing but angle of refraction, which is r. Okay, and this row is going like this. Okay, so we are going to apply the Snell's law in this question. Okay, this is mu2 and this is mu1. Always remember in the real and apparent depth cases that you have considered first medium from where the ray is going. So ray is going from which medium, or ray is coming from which medium? Ray is coming from m2, mu2. Okay. So we would firstly consider this, and then secondly we consider this. So learn this concept कि इंसिडेंट रे की डायरेक्शन में ही हमें मूव ऑन करना है. ठीक है. mu2 will be the refractive index of that medium from where the ray is coming, from where the incident ray is coming, and mu1 is the refractive index of that medium from where ray is going. Okay. So this ray is traveling from medium 1 having refractive index mu2 to medium this having refractive index of medium mu1. So apply Snell's law. Apply Snell's law. What do we get? We will apply the Snell's law like this. Mu2 sin I equals to mu1 mu1 sine r. Okay, so this is the Snell's law. Although I have tell you that how do you apply the Snell's law, but for these cases, these are the very important cases. Okay, real and apparent depth cases, you just apply the Snell's law. You starting applying Snell's law from the medium where the ray is coming and from the where ray is going. So start applying the Snell's law from where the ray is coming. The ray is coming from refractive index mu2 and going to refractive index mu1. So we have applied mu2 sine I is equals to mu1 sine r. Got it? So from this is the equation number 1 we have. Okay. Suppose this is the real, this this has to be supposed this is the real depth of this liquid, this object, and this is the appeared one. This is the appeared one is represented by D. Okay. Because if the observer is here, ठीक है, so observer को रे कहां से आती दिखेगी? Observer will see the ray coming from this point. ठीक है, so observer को लगेगा कि position of the object is here, not here, but this is the real depth. Okay, and this is the actual depth that we have. Okay. So we are going to calculate the value of R and D. Suppose this point is nothing but A. Let me just change the color of ink. Okay. This point is A, this point is B, this point is C, and this point is D. Okay. So in triangle ABC. Okay. What the value of this angle? This angle is I, so this angle be I. Z जहां पे बन रहा हो तो angle will be same. ठीक है, this is a formation of Z, so angle will be same. This angle is I, this angle will also I. So in triangle ABC, what is the value of sin I? These are the paraxial rays, so we would consider, firstly I will write this for paraxial rays. Okay, so sin I would be considered as, because I is very small, so sin I would be considered as tan I. Okay, got it? So if you apply it, then this equation would become mu2 tan I equals to mu1 tan R. Okay, got it? Yeah. So applying the value of sin I is equals to tan I, and also sin R is equals to nothing but tan R. Okay. If this angle is R, what will be the value of this angle? What will be the value of this angle? This angle is I, and this angle will be R. So this angle will also R. Okay, got it? From the normal, it is the angle making this ray, and from the normal, it is also the angle making by this ray. So these rays are same, and these are normal, so angle will be same. So this is R. Put the value of tan I in triangle ABC. Triangle ABC, what is the value of tan I? Tan I is nothing but, what is the value of tan I? Tan I is the perpendicular over base. Perpendicular is BC, base is AC. ठीक है, in triangle ABC. BC की value क्या है? What is the value of BC? BC is nothing but this shift. The value of this shift we would keep is as it is. ठीक है, as it is. BC would be kept as it. And this base is CA, yeah, AC, and AC is the real depth, so it is R. So tan I here is BC over R. In triangle, yeah, DBC, tan r is equals to again BC by, but this length CD, BC by CD is nothing but the apparent depth, which is D. ठीक है. Now, okay, so we have this equation, equation number 1, and we have got the values of tan I and tan R. So in triangle ABC, the Snell's law is there, mu2 tan I equals to mu1 tan R, and we have the value of tan I and tan R. So mu2, what is the value of tan I? Tan I is BC over R. Okay. So I'm doing it here for the your clarification. Okay. So mu2, put the value of tan I. Tan I is BC over R. BC over R. Mu1, what is the value of tan R? It is BC over D. BC and BC will cancel out. So we will have mu2 by mu1 as R over D. So this is the formula that we have. Okay. Got it? Mu2 by mu1 is equals to R by D. So if anyone has any kind of doubts, just ask in this question the concept that I have taught to you. Okay. Otherwise, this is the last topic of this discussion. Okay. So if anyone has any kind of doubt in the previous lesson also, they can ask. This formula will be look like this. Mu2 by mu1. Just note it from here. Real over apparent. Okay. In the next lecture, we will discuss most of the cases related to the real depth and apparent depth, velocity of fish and bird, okay, and total internal reflection. Okay. So here we are with this. So if you have any kind of doubt in this concept on the previous one, you can just write it in the chat box. Otherwise, the lecture has been over. So I'm just stopping this. Okay. Yeah. So thank you so much, guys, for attending the lecture. Okay. I hope you would understand what are the concept that I have taught to you. Okay.